So we will move to question number 2 quickly. So we have X, which is an element in the third period. So remember, so third period, we have sodium, magnesium, then we have aluminium, silicon, then we have phosphorus, sulfur, chlorine, argon. Okay, so these are the elements. And its first 5 successive ionization energies. So remember, what is successive? Successive means first you remove one electron, and then you remove another electron, then you remove another electron. But each case you need to understand the charge is different, because when you remove one electron from the neutral state, it is okay. But when you want to remove the second one, you are removing it from the +1. But when you give this successive energy, there will be not much difference when you are in different electrons. But when there is a difference in periods, there will be a higher difference in the energies. So you can see here, they have given 5 successive energy values. You can see the first one is 577. Second one is 1816. So there's a little bit different here. And then the second one will be 2744. So the difference is more or less the same here. So there is not much difference in between these three. But when you go from the third one to the fourth one, you can see there is a difference of around 8,000. So this should gives you the idea. Now the fourth electron is not removed from the same period. This should be from another shell. That is the idea. So you can imagine these 3 electrons, 577, 18, 16, 27, 44. So these 3 electrons should be some outermost electrons, and then this 11, 577 should be an inner electron from the other shell. So more or less, they have given the next one is 148842. So this is very close to this one based on the comparison of the energy. And more importantly, they have given another information. So X react with both dilute HCl and NaOH. So this is very important, because only amphoteric elements will react with acids and bases, and we have only aluminium here. And you know, there is 3 electron, outermost electron, as our prediction goes. So surely this should be aluminium. So identify element X. So element X is aluminium. This is straightforward. Then you can write down the configuration: 1s to 2s to 2p6 and 3s to 3p1. Okay. And give the most stable positive oxidation state. So you know, aluminium is more or less will be present in +3 oxidation state. You can write like this, or you can just put like this in the Roman form, +3. Okay, so then you have to give the balanced chemical equation. So we will write down the equation here. So basically what is happening here, aluminium with HCl, so it will form AlCl3, which will give you H2 basically. The other one is aluminium with NaOH, will give sodium aluminate and H2O. Okay. The idea is you need to balance this one. That is the first thing. And this is how it forms the aluminate. So if you don't remember about the aluminate formation, basically what you have to do here is you get the most stable one for Na2O. Okay, so this is the most stable form. And when you go to aluminium, you know, this is Al2O3. And when you add, this will be Na2Al2O4, the total form of the oxide. And then you get the most stoichiometric, the lowest one. So this will be 1 sodium, 1 aluminium, and 2 oxygen. So this is the aluminate, AlO2 minus that is going to form. Okay, so that is how this sodium aluminate comes. This is just a small trick to identify, but there is no point. If you know the reaction well, that is the easiest way to identify this product. And more importantly, they have asked these things in the question, so you can write down these two now. X burns readily in air to air or oxygen to form an oxide, so this should be aluminium oxide, so Al2O3. Okay, and then write the balanced chemical equation for the reaction when X. What is X now? It is aluminium with Na3 minus and NaOH. So can you remember this point? You can use the chat box very quickly. Do you remember that part? Do you remember where we discussed this one? I need answers very quickly because I have to move very fast. What is this reaction is mainly used for, if you can remember? We have discussed that before. So I am waiting for your answers. So do you remember this place where we discussed about the anion analysis? Okay. So if you remember about the nitrate identification, I told you you can react it with aluminium and nitrate with in the basic condition. There will be ammonia that is releasing. Okay. So this can be either aluminium or you can use zinc as well, or either even copper. So you can understand aluminium, zinc, or copper when you have nitrate. So it will give ammonia. But in fact, in the identification, if you have NO2 minus, either NH4 plus or N3 minus, there can be a contamination, like you cannot exactly tell whether this NO3 minus is present or not. Okay. So you need to write this balance equation. So in fact, I will just elaborate this thing a little more because I feel like this could be important. I'll quickly actually tell what is happening in these reactions. So because normally people don't understand what is actually happening, right? So think about this, right? So basically you have NO3 minus, okay, that is going to undergo a transition from like the difference in oxidation state from NO3 minus to ammonia. This is one process that is going to happen, right? And remember, this is in a basic condition. So we have an oxidation and reduction process going on. So let's just try to balance this one. So here you have one nitrogen and 3 hydrogen and 3 oxygen here. So I can put 3H2O here, and you have 6 hydrogen and 3 hydrogen. So there will be 9 less. So I'm going to put 9H plus into this side. But this is basic medium, so I will put 9OH minus to this side as well as this side. Okay, so 9H plus and 9OH minus will give 9H2O basically. So there is 3H2O, so I can cut these two and I can put 6H2O. So you remember the normal method, you first try to balance the same way as in the acidic medium, put 9H plus, then put same number of OH in the both sides and combine to form water and cut. That's it. So here you have 6H2O, NO3 minus, ammonia, and 9OH minus. Then you need to balance the charge. So there is 9 minus here and there is 1 minus here. So I can add like 8 electrons. Okay. So in this reaction, this is one process that is happening. Nitrate is converting to ammonia. Okay. The other process that is happening, you add aluminium. So aluminium, what it undergoes is it goes to AlO2 minus. Okay. So you have aluminium here, you have aluminium here, so you have two oxygen. So I'm going to add 2H2O to this side because to balance the oxygen, and there will be 4H plus, 4OH minus, and 4OH minus. So there will be 4H2O here. So I can cut this H2O and put 2H2O here. Okay. So atoms are balanced now. Then when you come to the charges, so here there will be -1, there will be 4 minus. So I have to add 3 electrons here. Okay. So you can understand this is the reduction process, that is nitrogen going from +5 to -3. And here you can understand the oxidation, it goes from 0 to plus something. What is it? +3. Yeah, there's oxidation more stable. So +3. So now these two reactions are the main reactions that is happening in this particular medium. And here then there is 8 electrons. So you need to add these two. So I will multiply this by 3 to make the total electron count 24. And here there is 3 electrons. So I will multiply this by 8 to make total electron count 24. So if I multiply by this by 8, so there will be 16 here. And this will be 8, 8, and there will be like 8 into 4, that is 32. And if you multiply this by 3, and there will be 18, 3, 3, 27, right? So here there will be 27 OH, 32 OH, so 5 OH minus, and 16 H2O, 18 H2O, there will be 2 H2O. Okay, so primarily when you add all these three, I will use blue one, this one, okay, and here there will be ammonia, and there will be aluminate, aluminium, 5OH minus, and you have these things on this side and these things on this side. So this is the overall entire reaction. Okay, so what normally students do is they just remember the overall entire reaction because it will be easy for them to keep that in mind. But still you need to know what is actually happening in this reaction. Okay, so the idea is there is a reduction where nitrate is going to ammonia, and there is oxidation where aluminium is going to aluminate. Okay, so this is the typical reaction that is happening in this nitrate identification, which is asked in the question. Okay, so I'm going to share screen again. Okay, so this is the overall reaction. If you want, you can remember, but this is not the final one. But when you do this by putting oxidation and reduction separately, and then you add, it will be very easy for you. Okay, now this is just not the full complete oxidation and reduction, just the overall reaction. Okay, so this is done. So you can write down the balanced chemical equation. So you can write down the oxidation, reduction, and overall. That's it. Write the formula of the chemical species of the X aluminium having the most stable oxidation state that forms in the aqueous media. So you know most cations, they normally present in the aqueous media as aluminium H2O6 hexa-aqua complex, or either it can be 1H plus that is removed to the media. For an example, this can be aluminium H2O6, okay, aluminium H2O6, and the charge is +3. This is the normal way, okay. Or either this H2O can be like OH. This can be either OH and H2O, OH, and H2O5. Okay, so there will be aluminium here, right? So if there is aluminium in +3 and you have OH which can be in -1, so +3 -1, the charge now will be +2. The oxidation state normally does not change, but the charge can be changed. Okay, someone is kicked out, right? So the idea is, what you need to know here is, since it can give an H plus, more or less this is an acid. So when you add a small amount of solid sodium carbonate, which is going to react with one of the H that is given by this aluminium H2O6 complex, which then you can observe bubbling, because CO2 will be emitting from the reaction between sodium carbonate as well as the H plus that is giving from this aluminium complex. Okay. Then give one use of element X. So this should be straightforward, because you know what is the main use of aluminium. It is used in the cooking utensils. So that is the main one. And even aluminium is used in aircraft manufacture because it's strong but light. So which is very good. So you can write one use that is very simple. Okay. So this sum up the part A of the question number 2. Then we will move on to test tube things. So you have labeled test tubes that are given A, B, C, D, E, and you have given some of the compounds that you necessarily need to identify. And you have given magnesium nitrate, sodium carbonate, KCl, zinc sulfate, and lead nitrate, which is going to be your solution that you need to identify. Okay, so we will discuss part by part. So when you add barium chloride to the solution A, it says there is a white precipitate that's soluble in hot water. So when you read this thing, okay, automatically you should come to a point. This could be lead chloride, because we have discussed this in the cation analysis in many times. Even in the previous paper, I have told you, when this is lead chloride, it is soluble in hot, and when you cool down it, the precipitate starts appearing. Okay, so we need to check whether there is a lead solution, lead something. So here we can see magnesium nitrate and sodium carbonate, KCl, zinc sulfate, and here there is lead nitrate. Okay, so when you add barium chloride to lead nitrate, there will be lead chloride plus barium nitrate that is forming. Then you need to balance, because I am telling these reactions also because they have asked about all the precipitates reaction that is happening here and all dissolutions that is going to happen here. So you need to write all these reactions. So I'm telling here, in fact, all the things that we necessarily need. So your solution A is lead nitrate. Why? Because when you have this barium chloride plus lead nitrate, there will be the precipitate lead chloride PbCl2 plus barium nitrate. That is the reaction. And when you add ammonium hydroxide, so lead, it will form lead hydroxide. So PbOH twice. That is the normal precipitate, and ammonium nitrate is formed. So then you can balance the reaction as well. Okay. Then you can see a white precipitate is formed when barium chloride is added, insoluble in diluted HCl. So if you can remember, we are always talking about this insolubility nature. When you have many of the cases, we talk this with the sulfates. When you add barium chloride to sulfate, it will form barium sulfate, which is not even soluble in nitric acid. So we can check whether there is a sulfate. Yes, there is sulfate. So zinc sulfate, which is with barium chloride, will form barium sulfate and zinc chloride. Okay, so there will be barium sulfate here. You still have barium sulfate precipitate, which is even insoluble in DLHCl. So this should be very straightforward at this point. Okay. And then zinc sulfate, when you add ammonium hydroxide, so it will be form ammonium sulfate and zinc hydroxide. So this is straightforward again. This is the white precipitate, which is zinc hydroxide. And C, a white precipitate soluble in diluted HCl. So from this one, you cannot get a direct conclusion because it is difficult to predict directly. Okay, but it forms a precipitate. Don't forget that. And when ammonium hydroxide is added, so this is a clear solution. So more or less, this could be a clear ionic compound. So when you go, so we are remaining with sodium carbonate, KCl, and magnesium nitrate. So we will check the reaction with barium chloride. So when you add barium nitrate, magnesium nitrate to barium chloride, so there will be magnesium chloride and barium nitrate, which is going to be a clear solution. And when you add sodium carbonate to barium chloride, there will be barium carbonate and NaCl. So think about this. And sodium carbonate, ammonium hydroxide, there will be sodium hydroxide and ammonium carbonate, which are clear solutions. And even KCl with barium chloride, there will be no reaction. And KCl with ammonium hydroxide, there will be KOH and ammonium chloride. Still, it is a clear solution. So when there is two clear solution, it should be surely KCl because there is not much reaction here with the barium chloride. But with the reaction with ammonium hydroxide, it still gives ammonium chloride and KOH, which are not precipitate at this level. Okay, because KOH is highly soluble in stroke base. So you can understand it should be clear solution. But sodium carbonate, when you add barium chloride, it should give a white color precipitate, which is here in C. So our C is sodium carbonate, but when you add ammonium hydroxide to sodium carbonate, there will be no precipitates, which gives a clear solution. And the two clear solution that we are talking here is KCl, as we explained before. And we are remaining only with magnesium nitrate, which forms clear solution, and a gelatinous white precipitate, which is magnesium hydroxide, that is going to precipitate out. Okay, so you can write down the reaction. That is what they have expected here in part 2. First, you need to identify the solution. So A is lead nitrate, and B is zinc sulfate, and C is sodium carbonate, D is KCl, and E is magnesium nitrate. Okay, so all these are given. You can write down the precipitation reactions. Okay, and dissolution. So dissolution is not much. For an example, now here it forms the white precipitate, which is lead chloride. So you can write down. So the lead chloride, you need to write lead chloride solid, and you need to put the arrow like this, and on top you can put the heating mark. And when you heat, what is normally happening, it dissociates into its ions. So basically a Pb2 plus. Here it is aqueous, and 2Cl minus. Okay, 2Cl minus. Still it is aqueous. And here this is solid, aqueous, aqueous. So this is how you can explain the dissolution of the precipitate. Okay, for an example, this one. And here you need to explain in the excess NaOH, it is soluble. So you know that zinc hydroxide is formed. Then zinc hydroxide, you put another ammonia. Then you write down zinc tetraamine 2 plus complex. Okay, so you can write down that here. And there is no other dissolution of precipitates here, but there is here in this HCl. So you know when you add barium chloride to sodium carbonate, there will be barium carbonate. Then barium carbonate, so you should know barium carbonate reacting with HCl. So this is the other dissolution of the precipitate, the main one. So there will be barium chloride, BaCl2, and H2O and CO2 that is forming. Okay. And don't forget to write down the balanced equations. Okay, because they are asking about the balanced chemical equation. Writing the this chemical equation is straightforward. So first try to write down very quickly, and then try to balance all the equations very quickly. Okay. So this part is nice and done. This is the same trend as previous question. So the first goes with the Lewis structure and periodicity concepts, and the second one normally goes with the inorganic S and P. So here it's very same. And the third one.